Individual capacitors can be connected together into combinations having either a larger or smaller capacitance. Here I have a number of identical microcapacitors, each with a capacitance of around 10 nanofarads and a maximum voltage rating of 10,000 volts. I can check their capacitance using this capacitance meter. And here we have a capacitance of 10.5 nanofarads. If I take two of these capacitors, I can either connect them in parallel, like this, with both the top plates connected together and both the bottom plates connected together, or I can connect them in series, like this, with the bottom plate of the first capacitor connected to the top plate of the second capacitor. Let's look at the parallel combination first. In parallel, the total capacitance is doubled, whereas in series, the total capacitance is halved. Now, I can keep adding capacitors in parallel, and the total capacitance is given by the formula C total is equal to C1 plus C2 plus C3. While if I keep adding capacitors in series, the total capacitance keeps decreasing according to the formula 1 over C total is equal to 1 over C1 plus 1 over C2 plus 1 over C3. Now, you may be wondering why you would want to connect capacitors in series if the total capacitance keeps decreasing. The main advantage is that you can charge up a series combination to a higher voltage, or to use better language, potential difference. This is because the maximum voltage rating of each capacitor in series adds up. So each of these has a voltage rating of 10,000 volts. So that makes 10,000 volts plus 10,000 volts plus 10,000 volts, giving us a total voltage rating of 30,000 volts. This is because when you charge up a series combination by connecting them to a battery or power supply, they all store the same charge Q. But the total voltage is shared between them according to V is equal to Q divided by C. However, when you charge up a parallel combination of capacitors by connecting them to a battery or power supply, they all charge up to the same voltage or potential difference as the power supply, but now the maximum voltage rating is just that of the lowest rated capacitor.
This is an impulse generator. It's used to create artificial lightning in the lab. It consists of 10 60 nanofarad capacitors connected in parallel. Now we charge them all up to 100,000 volts, and then we use these spark gaps to reconnect them in series. Now when this happens, the 100,000 volts across all 10 capacitors adds up to give us 1,000,000 volts. And we're going to take that voltage and we're going to discharge it all right here across this gap to give us lightning.